Good afternoon, everyone. I hope you all had a fantastic lunch. Can I have a show of hands here? How many people use Netflix? Quite a bit. I still see some hands down, so I'll give you guys a couple of minutes to log onto your phones, open Netflix, be a subscriber. The content is great. I watch it all the time. All right. So why don't we take a journey back in time to the holidays of 2022? Think about what were you all doing during that time. I'm sure it was a joyous time. I, for once, was spending time with my family and friends, opening up various presents that I got from different people. When we were getting back in January, we didn't know that there was a present waiting for us, engineers at Netflix, which was not so pleasant. In this talk, we'll slowly unravel the layers of that gift and see how the journey went through. So it was the weekend of January 13th, 2023, where the things were still getting back in groove. But we at EVCache team, we felt like 11 from the Stranger Things, where we knew that once we got the page, that something has gone wrong and that this can blow up really big. You will see lots of terms on the screen like EVCache, device history team, right? Replication. Don't worry, we'll walk you through all these terms one by one. This is a very familiar site, I'm sure, for most of us. This is the page that renders when you open netflix.com. And on the right, you see the call graph. This is the call graph that is responsible for rendering that single homepage that gets served to you. In this call graph are different microservices that Netflix is built on top of. Almost 80% of these requests are served by EVCache. That is how pivotal EVCache is. It's a tier 0 microservice at Netflix. So what exactly is EVCache? EVCache is a distributed, sharded, replicated key value store, which is built in-house on top of Memcached. It has tunables in-region and cross-region replication. By that, what we mean that apps can choose to tune their replication between different availability zones and cross-regions. EVCache can handle failures. It can handle nodes going down. It can handle availability zone failures. It can even tolerate the entire region going down. EVCache is topology aware. By that, our clients have the full picture of which key belongs to which node. It has the ownership information. It has which zones are deployed, which regions are available, and which node should I talk to. Our setup is completely scalable. We can scale it as per the customer RPS demands. It's both horizontally and vertically scalable as per the workload. And we have built a robust infrastructure on top of EVCache to ensure that the deployments are seamless and agnostic to the app teams. We also have a cache forming infrastructure which ensures that whenever the new setup comes up, the EVCache is ready to take the reads from the get-go so that you don't face the classic thundering herd problem. This is an overview of a single region deployment where you can see that apps can choose to talk to their local zone, or they can make the network calls cross-zone if the local zone is not available for some reason. Moving ahead, I'll give you a fleet overview. So we currently operate in 4 regions. We have US East 1, US East 2, US West 2, and Europe West 1. We have a total of 194 clusters across 22,000 servers. The key thing to note for this particular talk is the replication operations. We do a nearly 30 million operations per second for replication only, and total reads and writes are upwards of 400 millions per second. Our item storage is 2 trillion items, comprising 14.3 petabytes of storage. So what is this replication service that you have been seeing for a long time in this talk? Replication service operates in 2 different modes. It's essentially synonymous to Memcached APIs. How many people here are familiar with Memcached? Yeah. So Memcached offers a very simple API, get, set, and delete. Based on that, we have based our replication to support 2 of those modes, set and delete. In the set mode, your application in the source region sends a mutation or a write call to the source EVCache cluster. And at the same time, there is a library in the EVCache client which sends that call to the Kafka library. This is all happening in the source region. Once that happens, we have a replication service built in-house which dequeues that message from the Kafka in the source region and sends a cross-region network call to the target region where the replication service is deployed as a writer. This service has a EVCache client built in, and what it does, it replays that call to the target EVCache cluster in the remote region. Once the data is available in the remote region, your apps in the remote region can easily read the data from the remote EVCache servers. There is also a fail-safe mechanism for failed mutations through SQS, but that's out of scope for this talk. Let's move further to the delete mode. The key thing to note in the set mode first is that the value that is being played is replicated exactly as a set. So the set that came as it's played as exactly a set in the remote region. For the delete mode, the only change is the mutation that came in as a set, the replication service in the source region will be intelligent enough to know that, hey, this particular customer does not want the set to be replayed as a set. Instead, they want to invalidate that key in the other region. So it will replay that call as a delete call in the remote region. Let's tie all of this back to what happened on 13th January 2023. So at around 5 p.m., we got a page with the device history team saying that, hey, we are seeing discrepancy in the data across regions. They were using cross-region replication. The device history team at Netflix is responsible for maintaining the device histories of the users across in a single household. The flow of this particular use case looked like something like this. Device history team triggers a device removal in the source region, and then that event is broadcasted to all the other regions before it takes effect. So everything was fine up until the second stage, where the event was not taking the desired effect as it should. Let's talk about the impact. So this was for the famously announced password sharing feature that Netflix launched last year across the globe. And this was already supposed to launch on Tuesday, and this was on a Friday evening. So had we not scrambled enough to solve this on that weekend itself, we were at the risk of delaying a seriously announced global launch. Now to take you through the wonderful journey of debugging and to dive a little bit more into how we spent that weekend, I'll invite my colleague Prudhvi to walk you through those steps. Thank you. Prudhvi.
Thanks, Akash. How many of you have seen this email come to your email boxes? I still see a lot of hands down, so maybe something is not working, but we'll fix that. All right. Thanks, Akash. Again, I hope whatever that we have spent the initial 5-10 minutes on setting up the context was really important to help understand the debugging journey part. I'm going to be Bear Grylls for the next 5-7 minutes, taking it through the wild journey of debugging. So on Jan 13th, we got a page saying from the app team that, hey, we are seeing inconsistencies across the regions when we don't expect to see that. So we start off with our, the usual suspects of hopping onto our metrics, our alerts to see if there is anything jumping out of the everything seems to be fine. We go back to the application team saying that, hey, it looks like there is some bug on your end. The typical thing of pushing back and forth. So that continued for a couple of hours. And finally, the app team gave us one key piece of detail, which is, hey, I think we did upgrade, pull in a newer library, and potentially that could be causing some issues. This system does 30 million replication events per second, and we have hundreds of applications using the same replication architecture that we have shown. So really finding out one key and if the delete has not taken effect or not, finding that out is extremely hard. So what we tried to do is we wanted to create a shadow environment to isolate the issue and then try to reproduce the issue. So there were 2 parallel work streams that we divided ourselves into. One work stream focused on the application side where they were trying different commits, reverting certain commits to see if that was the bad cop, bad culprit, or the other parallel stream involved as looking into isolating the issue and shadowing the traffic. After 36 to 48 hours, we finally had a breakthrough with the issue. And to put it to simplify the issue, right? We were sending key dh:\test-1-0 in region A, and you could see there are multiple stacks involved. There was the application writing to Kafka. From Kafka, there is a Kafka reader, and there is also a writer in the remote region. So it is possible that the key could get mutated at multiple layers. I'll touch upon why we do key hashing in first place. We do key hashing primarily for 2 reasons. One reason is to reduce the memory footprint or memory cost on the server side when storing into Memcached itself. The other reason is if the keys are arbitrarily long, we could hash them, confine them to a specific size and reduce your network throughput as well. the issue that we have identified was we expect to see just one version of the hash key to be issued in the destination, but the key was getting hashed multiple times. And we knew this was the case, and then the other key information that the app team gave us was they have upgraded to a newer version of the library. So we started focusing more on where or how the hashing of the key could happen. And we noticed that there was just this one line of code that caused all the havoc for us. And the key thing here is the default behavior on this new replication library that the app team started using was trying to hash the key by default if the application scope property is not set, whereas in the legacy library this was set to false. To tie it back to the overall architecture, in step number 2, it was sending hashed key, and when the delete key is being issued in the remote region, we are again hashing the key again. So all the deletes are landing in remote regions, but they're all coming back with delete not found, whereas we expect them to be delete successes. So this was a fix where don't do any hashing in your replication library, and that got us out of the soup. And this is a graph that sort of demonstrates that the delete call started being successful once we got out of this issue. Now, the mitigation strategies that we had were, the short-term mitigation was in the slide where I have shown the app name.replication.hashkey. We could definitely overwrite it with false, and you could get away without doing any redeployment of your applications. So we did that as a short-term fix, and the long-term fix was to really work with the maintainers of the new Spring library to ensure that there is parity in default configurations. Now, this is almost a 48-hour ordeal for the entire team, and it was not just one team, but there were 3 other teams that are involved, and there were directors and VPs looking at us, trying to ask, hey, should we delay the launch or should we continue? So I would say, and at Netflix we have a DevOps model. We don't have a testing team, a developer, or we don't have such demarcations. Everybody is expected to write their code, deploy, fix in production. So I would say staying calm and is like a superpower when you're in a stressful situation. Persevere, because we were going in literally 5 different directions and 4 of them were coming back with negative results. But there was probably that one revelation that we had where the double hashing was happening. The dashboards were great, but sometimes they might need a fresh perspective to look at. When we were looking at the delete calls, all the delete calls were going through the remote region. There were no drop in the replication events or any of that. But had we paid attention to the fact that, hey, pretty much all of the deletes were coming back with not found, that should have raised an alarm on our end, which we missed during the debugging exercise. So I would say looking at metrics from fresh perspective would give you a probably it would have reduced the time to debug significantly. This is not my favorite, library upgrades. We take library upgrades for granted, but it's only when they start biting us back we go and try to scout for, hey, where the problem originated from. And one way to address this is to have solid end-to-end integration tests, especially for systems like these where there are so many moving parts. And adding end-to-end integration tests is easier said than done. I would like to walk the talk, but sometimes I fail doing this. But I think it was definitely a learning for us to make sure that we invest heavily in end-to-end integration tests. And finally, what really helped us significantly was the ability to shadow production traffic and creating a contained environment to be able to reproduce this issue. And I think this was sort of one window into how we navigated through an issue, but there are lot such issues that we deal with on a day-to-day basis. And with that, I think we are pretty much at the end of our presentation. Thank you so much for your time. Akash and I will be hanging around and take any questions that you might have. Thank you.